11.2 Surface areas of prisms and cylinders. The objective in this lesson is to find the surface area of a prism and a cylinder. We're going to start with some vocabulary. A prism is a polyhedron, so that means a 3D solid, with two congruent parallel faces. And this is very important. These faces, these two congruent parallel faces, are called the bases. All of your other faces are called lateral faces. And we name our prism using the shape of the bases. That's why they're so important. So if we look on our first diagram here, we look for the two congruent parallel faces. And there's one on top and there's one on the bottom, and those are pentagons. And so we would name this a pentagonal prism. Now our other faces are these rectangles around the middle. And if we look on the next diagram, where are our two parallel congruent faces? Well, once again, they're on top and bottom, and this time they are triangles. And so this would be called a triangular prism. And check it out, once again, our lateral faces are rectangles. And altitude is the perpendicular segment that joins the planes of the bases. Now we know what an altitude is. It's just the height of our prism. And so we take this segment here that joins the planes of the bases, and that would be our height. Prisms can be right or oblique. Believe me, you would prefer them to be right. A right prism, your lateral faces are rectangles, and your lateral edge is your altitude. So in our first two prisms here, this first one, we look for our parallel congruent faces, and this is a nice rectangular prism, which means it can be top and bottom, front and back, or left and right. Given the opportunity, I tend to choose top and bottom, because that makes it a little easier to see. So there's our bases. So our bases are shaped as rectangles. This would be a rectangular prism, and the height would just be your lateral edge between them. Now the next one's a little trickier. Where are your parallel congruent faces? Well, front and back are parallel, but they're not congruent. But check out the sides here. Not all of your bases are going to be on top and bottom. These are your two parallel congruent faces, and they are trapezoids, which means we would name this a trapezoidal prism. And our height, again, is the segment that joins those two. And this time it would be across the top there. Your other option is oblique prisms. And in an oblique prism, you can see over here, it's just a tilted prism. Some or all of your lateral faces are not rectangles. Now, we like prisms with rectangular faces. It makes everything a whole lot easier. In an oblique prism, it's the same. You do the same thing. You find which where your two parallel congruent faces are, and then the height, your altitude, just joins the planes of those two bases. In this book, we can assume that we are dealing with right prisms unless otherwise stated or pictured, which good for us. I think pretty much all we deal with is right prisms. Lateral area is the sum of the areas of your lateral faces, just like it sounds. So that's all of the rectangles around the middle. You find those areas and you add them all together. Surface area is the sum of your lateral area, so around the middle, and the area of the two bases, which makes perfect sense. If you want to find the area of the surfaces, you're just going to add all of them up. Let's look at our first problem here. We want the surface area of the prism at the right using a net. So what type of prism do we have? Well, this is one of those where we can pick wherever we would like for our bases. So I'm just going to pick top and bottom here. And we have a nice rectangular prism. And the height is just going to be that. And I like to label it height of the prism, because we're going to have a lot of different heights that we're dealing with, so keeping the height of your prism separate is a really good idea. So now we're supposed to use a net to find the surface area. So we just draw out a net, we unfold all of the pieces, we label our dimensions, and now we have 6 rectangles. And we know that the area of a rectangle is just base times height. We find the area of each of our rectangles, we add them up together, and we find the surface area of our prism is 94 centimeters squared. So very easy, very straightforward. And now it's your turn, so go ahead and pause the video and do the next problem. Okay, this was a little bit of work, but it wasn't too bad. We drew our net, labeled our dimensions, and what we found is we have 2 rectangles, the blue ones here, that are 5 by 12. Area is just base times height, get 60 centimeters squared. We have 1 rectangle, the purple one, which is 6 by 12, and just do the area of that, 72 centimeters. And then we have 2 ends, the green ones here, that are triangles. Now, lucky for us, they are isosceles triangles, which means when we draw in the altitude, we know that it also bisects the base, which means we have a nice right triangle that has a bottom is 3 and its hypotenuse is 5. That means we can find our height. And you can use the Pythagorean theorem and get the height is 4, or hopefully you recognize this is a 3, 4, 5 Pythagorean triple. It's a 3, 4, 5 right triangle. Either way, we now can find the area of our triangle. Don't forget the base is 6, not 3. We're doing the entire triangle here. And we get the area of that triangle is 12 centimeters squared. So when we do surface area, we have 2 blue rectangles plus 1 purple rectangle plus 2 triangles of the bases. We add them all together, and the surface area of our triangular prism is 216 centimeters squared. Now I can tell you're already going, oh my goodness, that's a lot of work. There has to be a better way. Well, of course there is. This is math. And so we always have shortcuts that we can use. We can develop formulas that let us make shortcuts. Now, for any right prism, we're going to be able to use the formulas we make here for any right prism. So look at your rectangular prism here. When you unfold the lateral faces, what do we end up with? We end up with a nice rectangle. And we know how to find the area of a rectangle. The area of a rectangle is just base times height. Well, the height is easy. We know that it's just the distance between our 2 bases there. It's the height of the prism. So that's easy enough. But how are we going to find the length of this base? Well, it's the length of all of our rectangles. And where does that come from? Well, look at what happens when it's folded up. It's this length plus this length plus this length plus this length, which is just the perimeter. So the length of our base is just the perimeter of the base of the prism. So we now have a base and a height. And these are our lateral faces. So that's our lateral area. And then what do we have left over? Just finding the area of the two bases. So that takes out a lot of these steps. So let's look at our formulas here. Lateral area is the perimeter of the base times the height of the prism. And this is why I told you need to keep the height of the prism and label it separately so that you know what it is. And then our formula for surface area is just our lateral area plus 2 times the area of the base. And we have a new letter here. Big B is area of the base. And so keep big B separate. This is why it's so important to write your formulas accurately. We're going to have a lot of H's and a lot of B's, and they're all going to be different, so you need to keep them separately. Well, let's take a look at how this works. Let's find the area of our prism using a formula. The first thing we're going to do is figure out where our bases are. We find the two congruent parallel faces, and those happen to be the triangles on the top and the bottom. So step 1 is to find the perimeter of a base. Well, how are we going to do that? I am going to draw my triangle here and label it. We know that this side is 3 and this side is 4. And if you were paying attention a few minutes ago, you know this is a Pythagorean triple, a 3, 4, 5 right triangle. You could also use the Pythagorean theorem if you don't recognize your Pythagorean triples. And now we can find the perimeter. We simply add it up, and our perimeter is 12 centimeters. So we have a perimeter now. The next step is to find the lateral area. We know the formula for lateral area is the perimeter of the base, which we have, times the height of the prism. And we know the height of this prism is the distance between the two bases, which is 6 centimeters. So our lateral area is 72 centimeters squared. So we now have a lateral area. And then we need to find the area of the base, which is easy enough to do. We have a right triangle. We know that height is always perpendicular to the base, so we know that we have the height of our triangle here and the base of our triangle. Notice how many bases and heights we're dealing with. Keep them separate. And we find out that the area of the base is 6 centimeters squared. That is going to let us find the surface area of our prism. Remember, surface area is lateral area plus 2 times the area of the base, because there's two bases. So our surface area is now 84 centimeters squared. So that's a lot easier than doing out all of the net. So it looks like it's your turn. Go ahead, pause the video, do one step at a time, and I think you'll be able to do the next problem. We did this problem. First thing I did was to find my bases, and I looked for my congruent parallel sides. They are the hexagons on either end. So I know that the number of sides is 6, and my side length is 6 meters. And then I can find the perimeter of the base. And we know that perimeter is number of sides times side length, so I got 36 meters. Step 2, I find my lateral area. Lateral area is perimeter of the base times the height of the prism. I have my perimeter of my base, and the height of the prism is the distance between the two bases, which is 12 meters. So I got lateral area is 432 meters squared. Step 3 is to find the area of the base. We know how to find the area of a hexagon. It's 1/2 AP or 1/2 ANS. We already have P. So I drew my triangle. I know that it is a 30, 60, 90 triangle because all hexagons are. And that means that my bottom side here is x, which is half of the side length, which is 3. And this, my apothem, is x square root 3. So my apothem is 3 square root 3. I plug it into my formula, and the area of the base is 54 square root 3 meters squared. Step 4 is to put it all together. My surface area is my lateral area plus 2 times the area of my base. So I can put this in simplest radical form, which would be 432 plus 108 square root 3 meters squared. Or we can put it all into the calculator and get 619.1 meters squared. So just do your steps one piece at a time, and you will be fine. Go back and review Chapter 8 and Chapter 10 if you need to. That brings us to the next portion of our lesson, and that is cylinders. So let's start with some vocabulary here. A cylinder is a solid that has 2 congruent parallel bases. Sound familiar? That are circles. So this is simply a circular prism. But we know how special circles are. Circular prisms are called cylinders. Okay? The altitude of a cylinder is the perpendicular segment that joins the planes of the bases. So nothing different than what we were doing before. This altitude just gives us our height. So our bases are circles, and the height is the distance between them, no matter where it is. We can have right cylinders, which makes life very nice, just like we had right prisms. And we can have oblique cylinders. And once again, if you have an oblique tilty cylinder, your height is simply the distance between the planes of the 2 bases. Now, the good thing in this book, you can assume that a cylinder is a right cylinder unless you are told otherwise. And lucky for us, 99% of what we have are right cylinders. Now, to do these problems, it's exactly the same idea that we just used for our polygon prisms, rectangular prism, triangular prism. It's just now we are dealing with circles. So we have our cylinder and we unroll it to form a net. And look here, once again, our lateral surface, we can't unfold it because it doesn't have any sides, but our lateral surface, once again, is just a rectangle. This is the height of the prism, and where do you think that we're going to get our base here? From the same place we got it before. Well, where does that come from? It's the perimeter. What is the perimeter of a circle? That's right. It's your circumference. So this perimeter is going to equal the circumference. So when we find our lateral area, let's look at our formulas here. When we find our lateral area, it's going to be the circumference times the height of the prism. And what is circumference? Circumference is 2 pi r, or pi d. I prefer to use 2 pi r, times h. So lateral area is 2 pi RH. And then surface area is our lateral area plus 2 times the area of the base. Well, what is the shape of the base? Shape of a base is a circle. What's the area of a circle? Pi r squared. Area of a circle is pi r squared. So surface area is your lateral area, 2 pi RH plus 2 pi r squared. So your lateral area here and your surface area, these two equations are good for every cylinder that you find. Lateral area is 2 pi RH, H is the height of your prism, and surface area is 2 pi RH plus 2 pi r squared. There's only two formulas that you need to know. Let's look at how this works on a problem. It says we have a cylinder that has a radius of 4 inches and a height of 6 inches. So we know this is 6 inches and our radius equals 4 inches. And so we know that this is the height of our cylinder. And we simply write our formula, substitute in radius, and we write this formula here. 2 pi RH, 2 pi r squared, substitute in, and we end up with 80 pi inches squared for surface area. This is in terms of pi. Now we could put that in our calculator and get a decimal if we wanted to. We multiply all the numbers that are regular numbers, stick a pi on the end of them, and then 48 pi plus 32 pi adds together just like any other number with a variable on it. It's like those are x's. So that means that it's your turn to do the next problem. Pause the video, give it a try. That was an easy problem. We were told that we had a cylinder, radius of 10 centimeters, height of 9 centimeters. We wanted the surface area. Wrote my formula, substituted in. We were asked for it in terms of pi, so I just didn't multiply that in. 380 pi centimeters squared. If we wanted to, we could have also put this into our calculator and got 1193.8 centimeters squared. So that's also possible. All right, let's look at our next problem. What if we are just interested in the lateral area? That's a possibility. When you're using a paint roller, you want to know what area does the roller cover in one full turn? Well, what is one full turn? That's just the circumference, isn't it? So here is the height of our cylinder. We know that our diameter equals 2.5 inches, and all we want is lateral area. So we have a formula for lateral area. Lateral area is either 2 pi RH or circumference is also pi d. So pi dh, simply substitute in, and we get the lateral area is 15 pi or 47.1 inches squared. So again, cylinders are pretty easy. Just use a formula. Now it's your turn. Do the next two problems. The first problem here was super easy. We had another roller that had a different height but the same diameter. So we were asked to find the lateral area again. How much area does the roller cover in one turn? And we got 3.7 pi inches squared or 11.8 inches squared. Just simply labeled everything, wrote the formula, substituted in. Now the next problem asked us what is the ratio of the smaller roller's height to the larger roller's height. So I did a height ratio here, small on top, large on the bottom. 1.5 to 6 are not friendly numbers. The easiest way to deal with a decimal in a ratio is to get rid of it. I multiplied both by 10, got 15 to 60, and just reduced down till I got a height ratio of 1 to 4. And then we were asked to find the ratio of the areas. So I did my area ratio and I decided to use my pi answers because pi cancels out nicely. And then I got rid of my decimal. This time I had to multiply by 100 and I reduced down until I got a 1 to 4 area ratio. Now, bravo if you wanted to square your height ratio to get your area ratio, but you have to be careful. These are not similar figures. The sides are not proportional. We have the same diameter and different heights. So the diameter would have to change in proportion with the heights if we had similar figures. So good if you remembered that, but you have to be careful. These are not similar figures. So our area ratios for similar figures does not work. Anyway, I believe you could do well on these problems. Just make sure that you, number one, find your bases. That will tell you the name of the figure and everything else you need to know. Label, label, label everything carefully. Keep the height of your prisms and cylinders separate from everything else. And then write your formula, the entire formula, and substitute in. Then you just simply solve for your unknown. Just go step by step, and I am sure you will do quite well on these problems. Don't forget to do your video quiz and enjoy your homework.